Okay, so in this video, I'm going to talk about what happens with arc length and discontinuities at dy dx, so when there's a discontinuity at the derivative. And I apologize in advance if I sound a little stuffed up. It's because I'm fighting a cold, but the show will go on. Okay, so you should understand the basic arc length formula before you watch this. This is a little bit more of an advanced version of that. So to motivate this, so what's the issue with finding the arc length of y equals x over 2 to the 2/3 from 0 to 2? So what I strongly recommend that you do is that you pause the video here and that you take the derivative of this. I think this is a good moment to test your derivative skills. So pause and hit play when you've got it. So this function is going to require that we use the chain rule. This is x over 2, so that's an inside function, and then 2/3 is the outside function. So I take the derivative of the outside, and then the derivative of the inside is 1/2, so there's all the pieces of my derivative. And so when I multiply everything together, I get 1/3 times 2 over x to the 1/2. And so going back to my question of what is the issue, well, the problem is that x equals 0 does not exist here, and that's part of our interval. So when this happens, we can rewrite the function in terms of y, and we can integrate with respect to y. And so just to show you what that looks like, it's the exact same formula. You're just going to switch everything in terms of y. So let's go ahead then and finish this particular example. Okay, so the first thing that I need to do is I need to rewrite this function in terms of x. So once again, I think this is a great place for you to pause the video and you to see if you've got the algebra chops for that, and if not, then you can hit play just to see the answer. But I would, math is not a spectator sport, so I would pause first and try on your own. Okay, so to do that, so first I need to start by taking 3/2, so the reciprocal exponent of each side, that will allow me to cancel out the exponents here, so that I'm left with y to the 3/2 equals x over 2, and then multiply both sides by 2 to get x equals 2y to the 3/2. Okay, now the other thing that I have to do is I have to figure out what are my limits of integration. So I need to go through and I need to plug in both of these to find out what the corresponding y coordinate would be. So if I plug in x equals 0 into my original function, this will just be y equals 0 to the 2/3, that equals 0. And then again, I plug 2 into the original function, so that's going to work out to 2 over 2 to the 2/3, so that'll equal 1. So that means then we want to integrate from 0 to 1. Okay, so now I can actually work on building my integration formula. So once again, I want to encourage you to try this on your own. So I would strongly recommend pausing once again, taking the derivative, and just trying to see if you can set up the rest of the integral, and then hit play when you think you've got it. Okay, so I go ahead and I set this up. So notice this is dx dy, not dy dx, right? Because now we're integrating with respect to y. So anyways, so I'm just going to use the plain old power rule. This is actually an easier derivative to take. So when all is said and done and I sort out the algebra, I get 3y to the 1/2. Now I need to square that. So 3y to the 1/2, that's the same as 3 square root of y. When I square that, that's going to come out to 9y. And so now I can go ahead and I can set up the rest of my integral. So this is the format that I want to use. I already figured out what my dx dy squared is, and I know what my limits of integration are. We figured that out. It goes from 0 to 1. So here's what I need to integrate. Okay, so if you made it to this point, that's awesome. Once again, I want to encourage you to try to finish this problem totally on your own. You'll learn the most that way. Hit play when you think you've got it. So the only way you can integrate this is by using substitution. So my u will be 1 plus 9y, and so then I'm going to have to manipulate my du, multiply both sides by 1/9, so I have 1/9 du equals dy. And then I also like to change my limits of integration, so I've got all of that there. So now, when I set this up, my new integral is 1/9 times the integral from 1 to 10 of u to the 1/2 du. And so now I can just go ahead and integrate that. And you don't get a beautiful number for this. So what I get when I plug everything in is 2 over 27 times 10 to the 3/2 minus 2 over 27. The only nice way I can really think to write that is just to factor out the 2 over 27, or you can plug this into a calculator, and you get approximately 2.27, tomato tomato in my eyes. Okay, so that's it for this video. So it's just a short and sweet one. So I'm going to leave it at that, and I will see you guys next time.